So here is how it breaks down. So this is the most important page of this entire unit. These functions, sine, cosine, and tangent, sine, cosine, and tangent are abbreviated like this. It all depends on a right triangle. This only applies to a right triangle. So you see that 90-degree angle. If you pick a particular angle, so in this case, I've picked this angle that I've called theta. That's just a variable. Once you pick an angle, all right, let me pick a color that you can see. Once you pick an angle, if you draw an arrow going away from that angle, that is your opposite side. The hypotenuse is always across from the 90-degree angle. All right, that doesn't matter what angle you're looking at. The hypotenuse is always across from the 90-degree angle. The other side is the adjacent side. So we have opposite, adjacent, and hypotenuse. Once you have those labeled, the sine function is opposite over hypotenuse. The cosine function is adjacent over hypotenuse. And the tangent function, the tangent of the angle, is opposite over adjacent. So eventually I want you to memorize this. To help you, sometimes it helps to use this silly word. If you put all of these definitions together, it makes this word SOHCAHTOA. And I've circled the parts of SOHCAHTOA because the SO part stands for sine is opposite over hypotenuse. That's the first formula. The CA part, cosine, is adjacent over hypotenuse. And then TOA, that stands for tangent is opposite over adjacent. So if you can spell SOHCAHTOA, then you've really memorized the three trig ratios. This will make more sense as we do the examples. All right, so now jump over to the day 1 classwork with me. Okay, so the 53-degree angle is already labeled for me, so let's definitely circle that angle. Starting with the hypotenuse. Remember, the hypotenuse is always across from the 90 degrees, so that means this 5 right here is the hypotenuse. If I draw an arrow away from the angle, that is going to be the opposite side. So this is opposite. The remaining side is adjacent. So you always want to start by labeling everything. So the sine function, we will abbreviate it S-I-N. Don't say sin, it's sine, all right? Even if it's abbreviated like this, don't say sin theta, please say sine theta. But we write sine of 53 degrees. Do not leave out the 53. You have to write sine 53 equals. And sine is opposite over hypotenuse. So in this case, that's going to be 4 over 5. So that's how this works. And for this part of the lesson, we're just setting these up. So look at the next one. Look, the numbers are all the same. So this is still hypotenuse and opposite and adjacent. Okay, so cosine of 53 will equal adjacent over hypotenuse. So that'll be 3 over 5. Okay, and then again, hypotenuse, opposite, adjacent. But tangent of 53 is opposite over adjacent. So that'll be 4 over 3. So that's how we set these up. Okay, use the provided triangles to find the value of each. To find each value, give your answer as reduced fractions. So you have to pay attention to the angle that they put on the inside of the trig function. So in this case, it's cosine of angle H. So you should start by circling the H. Let's label everything. The hypotenuse is always across from the 90-degree angle. Okay, so that makes this the hypotenuse. If you draw an arrow going away from the angle that you circled, that is always going to be the opposite side. And then the remaining side is the adjacent side. So we have everything labeled now. But this is cosine. And we just learned that cosine was adjacent over hypotenuse. Adjacent over hypotenuse. So in this case, that will be 60 over 185. So we're going to have 60 over 185. You really want to have a TI-30XS multi-view like me. And if you do, then you can go 60 and hit the fraction button. So you have 60 over 185. Okay, so that's 12 over 37. All right, so that is the value of the cosine of angle H. The tangent of angle H. Well, that's the same angle as before, so we don't have to change the labeling system. But we learned that tangent is opposite over adjacent. Tangent is opposite over adjacent. So in this case, that will be, oh, you know what? We don't have the opposite side right now. There's no number there. There's an extra step that we're going to have to do to find that opposite side. And it's the Pythagorean, you have to do the Pythagorean theorem. All right, Bryce is saying that my screen is frozen, but it's probably actually Bryce's screen that's frozen. So Bryce, if you can hear me, actually, okay, here, I'll do this in case. Never mind. Okay, Bryce says never mind. Okay, we have to do the Pythagorean theorem, that whole a squared plus b squared equals c squared thing. A squared plus b squared equals c squared. The c squared is always the hypotenuse. So that's going to be the 185 squared. Okay, the a squared and b squared are the other two sides. Okay, so I'm just going to say x squared plus 60 squared. So these numbers are pretty big, but that's okay. So if I do 60 squared, all right, that's 3,600. So now I've got x squared plus 3,600. And I've got 185 squared. 34,225. 34,225. So now I need to subtract 3,600 from both sides. So I'm just going to go minus 3,600. Okay, so that's 30,625. So x squared is equal to 30,625. To get x by itself, you have to take the square root of both sides. So I'm going to do the square root of 30,625. So that is 175. So that was the Pythagorean theorem, and we use that to find the third side, 175. Okay, so now we can find tangent. All right, because tangent is opposite over adjacent, so that is going to be 175 over 60. And we need to reduce that. So 175 over 60, that's 35 over 12. Okay, The last one involves a different angle. All right, so we're going to have to change a couple of things. All right, let's not erase the 175. The hypotenuse won't change. The hypotenuse is always across from the 90-degree angle, so I don't have to worry about that. But I'm going to circle the F this time because we're talking about angle F this time. And if I circle angle F and I draw an arrow, that makes this the opposite side. And that means the 175 is now the adjacent side. So for the sine of F, looking at my notes, sine is opposite over hypotenuse. So that's going to be 60 over 185. And then we have to reduce this. But look, this is the same thing as the cosine of angle H. So we already know that's going to be 12 over 37. Okay, that is how you do it. All right, let me keep an eye on the time real quick. Okay.
Are we on the classwork?
We are on the classwork. We're on the classwork. Okay, we should be looking at the day 1 CW. Okay, so draw a triangle that has these 3 angle measures. All right, so let's draw that triangle real quick. Ooh, yellow is not a great color. Hold on. Okay, so we have 28 degrees. And we have 62 degrees. And 90 degrees, of course. Given that cosine of 28 is about 15 over 17, label all 3 sides. Well, let's start off with the fact that this is the hypotenuse, because the hypotenuse is always, always, always across from the 90-degree angle. Notice that they have 28 degrees is the angle inside the trig function. So we need to circle that angle. All right, so here is 28 degrees right here. Remember, if you draw an arrow going away from the angle, that is going to point to the opposite side. So that makes this the opposite side. And that means the other side here is the adjacent side. So we know what's opposite, adjacent, and hypotenuse based on the fact that we have a 28. So we need to know where the 15 goes and where the 17 goes. This is cosine. Look back at your notes. Cosine is adjacent over hypotenuse. So that means that this 15 is adjacent and the 17 is hypotenuse. Okay, so the 15 is adjacent, so that must go here. And the 17 is the hypotenuse, so that must go here. Now, they said to label all 3 sides, all 3. So we need to find the third side as well. But remember, if you have 2 sides and you need the third side, what you need is the Pythagorean theorem. So let's say if I put an X here. You know how the Pythagorean theorem is a squared plus b squared is equal to c squared. Remember that the c squared has to be the hypotenuse. A common mistake is to always put the variable over there. But no, it's the hypotenuse. So we're going to have x squared plus 15 squared is equal to 17 squared. So that's going to be x squared plus 225. What is this, like 289? I'm guessing. Let's see, 17 squared. Okay. And now I'm going to subtract 225 from both sides. So I'm going to have x squared is equal to 64. And then if we take the square root of both sides, we get x is equal to 8. All right, so that's why this last side over here is going to be 8. So we were to label all three sides, and there you have it, 8, 15, and 17. All right, now, based on your drawing, fill in the information below, reduced fractions. Okay, so we already have the 28 circled, so let's definitely start with that. The sine of 28. Okay, the sine of 28. Sine is opposite over hypotenuse. Okay, so that's going to be 8 over 17, opposite over hypotenuse. Tangent of 28. Tangent is opposite over adjacent. Opposite over adjacent, so that's 8 over 15. Now, be careful on the last few problems here. They all involve the 62-degree angle, the 62 degrees. So we need to change some things. The adjacent and opposite are going to be different now. The hypotenuse is still the hypotenuse. It's across from the 90 degrees. But this time around, we need to circle the 62. And if I draw an arrow going away from the 62, that tells me that this is opposite. And the 8 is adjacent. Okay, so as we do these last few problems, the sine of 62, and sine is opposite over hypotenuse. So that's 15 over 17. We've got the cosine of 62, and cosine is adjacent over hypotenuse. So that's going to be 8 over 17. And finally, tangent of 62, and tangent is opposite over adjacent. Opposite over adjacent, 15 over 8. Okay, that is how that works. And that's actually the end of the classwork.